I'll start by introducing myself. Hi, my name is Damjan. I'm the CTO of Posedio. My background is kind of standard software engineering track. I studied software engineering at TU Wien. Worked with backend technologies initially, so started with Kotlin and Java. Then also got involved a bit in front end, so full stack development with TypeScript and React. And then as cloud got more and more interesting, DevOps got more and more interesting. I also got involved in DevOps and cloud platform topics, mostly focused on GCP, but obviously also some experience with Azure and AWS a little bit. What I'm currently working on, or what my area of interest is right now, is this whole data mesh topic, which I will talk about today, where I explore how you can share data in an organization in an effective and organized way. So this is the topic for today. I want to talk about how you can unlock your data in your organization. I want to talk about the reference data mesh, implementation or architecture, and I want to talk about just sharing data in general and where this idea comes from. This is what I want to talk about, but obviously what's in it for you? Why should you listen to me? I will talk about the data mesh as a sort of software engineering paradigm that kind of follows this evolution and this shift in software engineering from the old way of working to the latest cutting edge methodologies. I will also provide a reference architecture so that you can see from a technical perspective what it looks like to have a data mesh, or at least what kind of tools you might need or what kind of processes you might need. But first, I would like to go over what the actual goal of the talk is and what you will eventually get out of this. So obviously, the big question for us is what to do with all this data. I mean, every company generates a lot of data. This is the first step. This is the obvious thing to do. Every department wants to generate data. Every interaction with a customer generates data. Every step in the manufacturing process generates data. Marketing departments obviously have a lot of data. Sometimes weird thing happens within our systems. Data is generated on its own without anybody really interacting with it. All of this data is somehow piling up in the company. We have the conventional wisdom that states, yeah, we should have more data. The more data we have, the better we can make decisions, the better we run the business. We end up with just data that is being generated and stored all the time. The big question for us as organizations is, what do we actually do with this data? So people tell you you should generate it, you should store it, it has value, but nobody really tells you what the value is. And really, we cannot, as developers, answer this question. It is actually not for us to know this, not for us to answer this. If developers get to decide how the data or what the data is used for and what data is needed and what data is not needed, then obviously the entire system would be built to serve developers. And what we actually want is data to be free in the company and to serve decision makers, to serve the people who actually need it. This means that we want to remove ourselves as developers from being the bottleneck in this data pipeline. We want to enable users to freely access the data and use it in a way that they find mostly benefits their desired outcome. So what we want to do is enable data-driven decisions. We want to enable our organization to experiment, to learn new things, to try new things, and gather data points that then can influence decisions. We want to outmaneuver the competition, and we want to be able to use the data in a way that will give us a competitive edge. And we see through research that exactly this data-driven decisions and how a company handles data or what it does with the data is a key predictor indicating success for a company. So finally, once we have all that, the only thing left to do is profit. For me, the goal at the end of this talk is that you can see the parallels between the data mesh approach as a paradigm shift when we talk about handling data, and other significant paradigm shifts in software development, which would hopefully indicate to you that this data mesh thing is not something new. It's just the next step in the evolution of how we deal with software and data. You will also understand the basic components of a data mesh, why they're there, why they're necessary for a working data mesh solution, and you will have a technical overview of what needs to be done to have a working data mesh. But first, in order to be able to do that, to see that data mesh is not a new concept, we need to take a step back, look at what we used to have in the good old days, and see how we got from that to where we are now when it comes to software development. So the good old days, obviously, waterfall models, monoliths everywhere. What do these things have in common? Or rather, what do the things that replace these things have in common? I think is a very interesting point and is an indication of where data mesh approach comes from and how it can actually help us deal with data. So we start with the waterfall model on the left side. What is it, or why did we have to replace it? I mean, obviously on paper it sounds good. You have a goal, you start working towards that goal, you test if your solution works, and eventually you reach that goal. We all know that this is not always the case in practice. The main reason behind this is that the people who make up the goal, the people who make up the solution, the people who test the solution, and the people who use it are not always the same, or almost never the same people. So it's difficult to get the solution just right because there's not enough expertise. And I don't mean expertise in terms of software development. I mean this cross-cutting domain expertise or domain knowledge that would allow you or allow the users of the solution to provide input for the design and building of the solution. We also know that the waterfall method is slow to react to changes. This is because once a step is finished, then the next step really builds on top of that. So we cannot really make any changes to the design during build time. And finally, time and budget estimations are nearly always wrong, and this follows the same reasoning. So it's very difficult when you try to predict something far in the future to be correct with your predictions. And it's very difficult to predict things when you're not really sure what is being built. I, as a developer, perhaps have no knowledge about rocket building, and then someone asks me to build a rocket. Obviously, I don't know how long it will take. I first need to learn how a rocket operates. What is the solution to this? We have the Agile paradigm shift. We switch how we build software to this Agile methodology. This can be Scrum, this can be Kanban, this can be any other Agile methodology. The general idea or what they're trying to do basically boils down to the same principles. The primary goal is first the team needs to decide on the work. So when you ask someone to estimate, it needs to be the person that does the work, that estimates and decides on the work. So the responsibility needs to be given to the people closest to the problem. Obviously, the next step that all Agile solutions or Agile methodologies prescribe is that you want to have whether internal or external customers or stakeholders, and you want to regularly show your solution or your product to these customers. This kind of helps you put you in this mindset of having a product, having a solution, having customers that whose demands you're trying to satisfy or whose needs you're trying to meet, which kind of focuses the entire thing and puts everything in perspective. Then we see that work is kind of reorganized to fit this self-organizing team. So if you have a team that can decide what kind of work to pull and what to work on, and they're aware that this is a product that needs to be presented to customers, then obviously they will organize in a way that benefits them and benefits their particular product and use case. But you need to make sure as an organization that work can be packaged in such a way that these teams can effectively work. So in essence, they need to be able to, in a self-service way, pull in work on packages, and then present them as finished outcome. And finally, we need to have some sort of centralized control, whether that's through a backlog or some feature prioritization or some other form of interaction and coordination between teams, because in the end, we don't want to have these little islands of functionality. We want to have, on an organizational level, an optimal solution, which means it's not enough to just tell the teams, here's what you're building, go and build it. But at some point, there needs to be feature priority, there needs to be a backlog, there needs to be a central control that says this is the expected outcome. This kind of brings us then to the next paradigm shift, or the problem of the right side that we saw before. This is this monolithic architecture and this clash between development and operations. And here we see that we have some very similar problems, or if not the same problems. So it's again very difficult to get the solution just right. In this case, I don't mean solution as in the business functionality. I mean solution as in actually delivering software. So software in this case would be solution. And it's very difficult to get it right because development optimizes for ease of development, they optimize for feature velocity, they optimize for their local incentives. Operations, on the other hand, optimizes for running the software, they optimize for stability, which means that when development develops something, they very rarely look into, or used to look into, things from the perspective of, is this maintainable? Is it stable? Will it run properly? And so it was difficult, obviously not because they didn't want to do it, but they just didn't have the expertise to build software that is maintainable, that is stable, that is scalable, and so on. Obviously, this is because of the lack of expertise, because development was one silo within the organization and operations was another. This again led to this slow reaction to changes. So basically, if you need a new feature as a business unit, you would ask development, so you would hand it off to development. Development would build something, they would test it perhaps, or another QA team would test it. This is another handoff, takes time. Then it would get handed off to operations. They would need to plan a maintenance window. They would need to roll it out. So all of this takes time. This is time that you usually don't account for. And therefore, once again, time and budget estimations are nearly always wrong. So this leads us to the next paradigm shift. This is this microservices approach and this DevOps methodology within software development. And here it all boils down again to a couple of key points. The first thing, when we talk about DevOps and microservices, we want the team to take responsibility for developing and maintaining the software. This is this you build it, you run it mindset. This means that the team is not only incentivized to look at feature velocity, but also stability. It takes the whole thing, the whole package basically, and it treats it as a single unit, and it forces the team to take responsibility for both parts of it, which stabilizes the whole process. The next step is to have the microservices as a full product. Whether that's an internal product or an external product is irrelevant. The idea is to expose it as a product with all the required functionality, whether that's authorization authentication, whether that's a UI, GUI or whatever, whether that's some sort of system for internal billing so that you can build services on top of services. In any case, the idea is that this service that your team builds and is responsible for is in essence a product. It's a product that you need to sell also to your internal customers, which means that you need to be very careful about stability. You need to be careful about usability. You need to be careful about making sure that it's actually feature complete, or at least it's stable and it progresses and it meets the needs of your customers. Then the next step is obviously we want to gain velocity and maintain stability. This means we need some sort of runtime platform, ideally a self-service platform where we can easily and simply deploy things. In our case, these products, these microservices. This is usually Kubernetes, could be also potentially something else. The goal is, it doesn't matter what the platform is, the goal is teams can easily deploy things without too much effort and with no external interference. This means when I want to deploy my service, I don't have to call a central team. I can just click a button and the service is deployed. And this is the key difference between DevOps and microservices as compared to this. I have my packaged code. I call the operations team. I tell them it's your problem now. And finally, again, we have this centralized component. This takes the form of either an API layer, as you can see in the diagram, or perhaps centralized security and governance, and usually some sort of service catalog where you can discover different services within the organization. What does this mean for us, or how does this compare? I mentioned in the beginning that I find these two paradigm shifts very similar. I believe they boil down to a similar thing. So on the left side, we have the objective, where the top level objective is that we want to give the responsibility or a thing to the people closest to that thing, so the people closest to the problem. If you think in Agile methodology, this is the team deciding on the work because the team is responsible for that work, so they should be able to get the responsibility and get the decision-making power on how to structure work. If you think in DevOps and microservices, the team is responsible for developing the service and the team is responsible for building or maintaining the service. This means that they're closest to the problem, they're responsible for both sides of the problem. The second objective is to present a finished artifact as a product to a customer. This is either done through this outcome presented as a product to stakeholders in the Agile methodology. This is treating microservices as a full product in the DevOps mindset and in the microservices approach. Third pillar is to have the self-service capabilities that lead to independence for the teams that work. This can either be in the Agile methodology, this reorganizing work in this self-organizing or self-service manner where teams can pull work and teams can decide what to approach and how to approach work. Or it can be really some platform like Kubernetes in the DevOps side, where you have a self-service approach and you can decide when to deploy and how to deploy without external interference. And finally, there's this centralized governance, which in the Agile methodology takes the form of feature priority or backlog or some sort of central control, project management that takes care of everything, makes sure that the outcome is aligned between teams. Or in the DevOps and microservices methodology, this is the centralized security, the API layer, the service catalog. So we've looked at two different paradigm shifts within software development. How does this correlate to the data mesh, or why do I start with this when I want to talk about a data mesh? I believe that the same objectives are what drives the data mesh movement. I believe that all three paradigm shifts tackle the same problem at different levels, and they aim to achieve the same outcome. This is increased agility and effectiveness by pushing decisions down to the lowest level so that independent teams can make independent decisions and the whole thing serves to optimize the outcome for the organization. So we see how the four pillars on the right side under data mesh match the objectives that we've seen throughout the presentation so far. These four pillars are exactly taken from the article that coined the term data mesh, and they are seen as the key enabler or the key requirement for having a data mesh in your organization. Of course, it's not enough just to have these four things. You need to have some extra magic on top, but these four things are the key things without which you cannot really have a data mesh. And we see how they match. So we have first the domain-driven ownership. The idea here is that The people who are closest to the data know and understand what the data is, what it means, and they need to own this data. They need to be the ones that decide whether a customer means an internal customer or an external customer. They need to decide whether a customer ID is the same as an analytics ID or is the same as a reference ID. So the people that are closest to the data, we call them the data producers, need to be the one that have ownership of the data, and they decide who else can get access to the data. They decide what the data should look like, how it should be stored, how it should be processed, accessed. Is there GDPR relevant data that needs to be hidden? Is there anything else that might basically cause any special use cases or any special cases to be considered? The second pillar is treating data as a product. So it's important that you don't just store the data or put it somewhere and describe it, but what you want to do is build a product, build something that other teams can use. This means that you have to have your data cleaned, you have to have your data easily accessible, understandable, and most importantly, you need to treat other teams as your customers. This means you fight for their business by making your product consistently and constantly better, and you don't just have it there and basically you force them to use it because this is company policy. This product mindset is really what drives you forward and what causes constant improvements or iterative improvements and makes sure that the quality of your data mesh basically stays at a high level. The third pillar is a self-serve data platform. What does this mean? It means that any team that wants to be either a data producer or a data consumer can go to this self-service platform and either upload data, store data, or download data without any external dependencies. Or let's say with minimal external dependencies, since potentially access needs to be approved. The idea is to remove barriers to entry and make sure that people can get started and can use the product as easily as possible. And finally, we have a term called federated computational governance. It's a bit of a complicated term, but what it boils down to is centralized governance, except it's not really centralized governance in the sense that someone looks at it, a central team looks at it, but this computational part means that it's automated. Reason being, usually you deal with so much data that it's nearly impossible for a real person to go through it and categorize it and enforce governance rules and policies. You need some sort of automation that will allow you to scan the data, tag the data with the appropriate metadata or access levels or categories or whatever, and then enforce governance rules such as access policies, such as who can see what, based on these tags and based on these categories that you provide for the data. So what does this all mean, or what does it look like in real life? I have prepared two reference architectures. One is a very simple overview. The other is a more complex, more full-blown architecture. Reality is usually somewhere in between. So one is the simple architecture of what you would need to have a system run. The other is a GCP example, so Google Cloud. The reason why I chose GCP is because I'm working right now on a project that uses GCP. But as I said, it's not always, so we don't, even in the project, don't go full GCP. Reality is somewhere in between. We use some open source products, we use some GCP products, and we try to make the whole thing work. Since at the end of the day, a data mesh is more of a paradigm shift in terms of software engineering and data engineering, and less an architecture blueprint. So the architecture should be or the data mesh approach is flexible enough to allow different types of architectures as long as these four pillars are followed. And the concept of having a distributed responsibility with centralized governance is kind of kept. So I will switch to the browser now so that I can zoom in a bit, and I will just go briefly over the components in this data mesh architecture that I have here. Initially, we have source systems. These are the data sources. On one hand, we have source system one. This can be a database. Usually, this is operational data. What do I mean by operational? These are either online transaction processing services or services that need to really have this asset transaction layer. So really respond quickly to a high load of transactions, but are not very good for analytical data. Source System 2, for example, is a streaming platform like Kafka or perhaps PubSub or something similar. What I'm trying to showcase here is that you can have different source systems. Ideally, your architecture should not limit you to a single system, but it should provide a modular approach where you can have different ingestion services that can connect to different source systems and ingest the data. I have here 3 data products. We have the data product on the left, the data product on the right, and the data product on the bottom. They follow a very similar approach. The key difference is the data product on the bottom is actually a product built on top of other products. Why did I put this here? Because I think it's very important to kind of think of this internal economy and internal services within the organization. So if you have a product called, I don't know, customer data, and you have a product called shopping data, then you can provide another product on top of that that combines these two and perhaps provide some insights into customer shopping trends. And this is really where the power of a data mesh comes forward, same as the power of microservices. It's not the components themselves, it's the interaction of the components and this networking effect. But to go back or to focus on perhaps one product, here we have 4 key components. One is the data ingestion part. This, as I mentioned, should be modular. It should allow for different sources. And the idea here is that data is copied from the source as is with as little change as possible. Then you have an ELT pipeline. This ELT pipeline, actually, it's not ELT, it's more like transformation pipeline, is responsible for taking the ingested data and transforming it in a format that you want to expose as your data product. This means refining the data, cleaning the data, making sure that the data quality is at an acceptable level for you and for your product, making sure that the data is consistent, naming is consistent, making sure that all of these things, schemas and so on, they're all at the level that you would expect from a product that you serve to customers. Data is then stored. It can be stored in different versions. So again, this part is modular. It can be stored in a database. It can be stored in file storage. There are different formats that you can use. In the end, the data product team should have the responsibility and the freedom to decide how the data is stored. And finally, there's a component that we call the data interface. This is basically how the data is exposed to the outside world. This can be through a table, so basically SQL. It can be code, Java code, whatever. It can be some machine learning models. It can be a REST API. Again, approach should be modular so that the product decides how they want to expose their data. Of course, they can have multiple ways of exposing the data, and then the consumer can decide how they want to access it. In addition to these components that every data product has, we also mentioned that we want to have a self-service platform. So there is usually a platform team that deals with the centralized governance, discovery, and metadata systems, among other things. By governance, I mean enforcing policies. I already touched upon this. The idea is that this system can access all the storage and basically scan the data for GDPR relevant data, for tagging, for categorizing, or for whatever governance policies need to be enforced. The discovery aspect is very important. It is basically a data catalog where you can register your data product, and a user or a consumer would go to the discovery API or the discovery UI, and would be able to look at what data exists within an organization, what data might be useful for them, for what they're trying to achieve, and what this data looks like. So basically short examples so that they can get a feeling for the data without actually consuming all of it. The idea is really just a sneak peek or a preview so that you can go there, you can browse, you can say, oh, shopping data, that's interesting, maybe I can get that, and then you request access through the data interface. And finally, we have the metadata store. Here we would save information such as is the data, or what is the freshness of the data, what is the lineage of the data, so what transformation took place, data provenance. Here we would have things such as GDPR relevant columns, so am I allowed to see everything? Am I allowed to see only parts of the thing together with governance? Here we could store stuff such as I don't know, custom tags that would help us then within a company make sense of the data. So this is really data that describes the data in a sense. And finally, we have the producer. The producer, as I said, would go to the discovery, get info on what the data looks like, where it can be found, and then the producer would connect directly to an interface and would ingest the data. In this case, we have this producer here that connects to two data products, but also we have this data product that acts both as a producer to the user here and as a consumer of the other data product here. And this is the interesting fact that you can build services on top of each other, and you can have services or teams that are at the same time producers and consumers of data. Which brings me to my kind of more complex setup. I will again switch over to the browser. This is how Google proposes that a data mesh could be implemented with a full Google stack, so all of their services. And we see here we have a lot of similarities to what I described in the simplified setup. So on one hand, we have the centralized services. We have the metadata with the tag template and the logical data organization, the lineage. We have the data discovery with Dataplex and the data catalog. We have the policy management. We have centralized logging, monitoring, data quality, and of course, billing. And we have the data marketplace where we can expose our internal data products and in effect serve them to internal teams, even with internal billing and cost allocation and so on. Then we have a centralized template that the data platform team provides. So this is basically a way for data teams to onboard onto the platform. They can come to this template, they can choose the services that they want to, and then this gets instantiated into a data product. We can have multiple products per domain. We can also have multiple domains within an organization. The key thing, if you remember, is that the team that has the domain knowledge is responsible for that domain. So you have a team that knows about customer data, they would be responsible for the customer domain, and there they can have two products, for example. We can see that within a product, you can choose different aspects out of this template. So for example, here you ingest data using PubSub. You can also ingest data using a Dataproc serverless approach. So this is basically a Spark cluster. You can use some pipelines such as Dataflow. You can go directly to a database. You can go to cloud storage. So there are different ways how you can ingest this data. Once you have the data ingested, we have the storage option. Storage can be in tables, storage can be in cloud storage, external tables, different databases, so document databases, can be in this AI terms in this feature store. So these are pre-trained models where data would be stored and so on. We have the data interface. So how do you access this data? This is usually done through these authorized views. So you get the limited access to only the data that you're allowed to see. This can be through this prediction API, which in essence is an HTTP request that calls the AI model underneath and offers predictions or inferences on the data that would help you predict, for example, stock levels in the future, or predict, I don't know, capability, resource utilization for cluster resources if you're planning a data center, for example, and so on. It could be also served as a Java application. So basically, you could have a Cloud Run serverless Java container which has access to the data. And then from there, it can serve the data either through HTTP, gRPC, or any other protocol that you want to use with your Java application. And finally, you have the metadata, which is served through the data catalog. Obviously, this has two parts. So there is the centralized part where the data catalog and data discovery happens, and there's the decentralized part where the tagging of the data itself happens. And finally, the entire thing is meant to be set up as a platform. So it's set up with infrastructure as code templates. This can be Terraform, or it can be the Google native cloud built. And you have centralized tools such as data pipelines that you can use to access the data of the different products. So to recap, the goal here is to kind of make sure that teams, exactly as with Agile teams and with microservices teams or DevOps teams, the teams can be responsible for the data they produce. The data they produce is treated as a product, which means it needs to guarantee a level of quality. It's easy for teams to onboard. It's easy for teams to get started through the self-service platform, and security and other central aspects, governance, they're managed centrally so that the organization can enforce policies throughout all the data products at the same time. So this is in essence my presentation. If you have questions, please feel free to ask.